Alright, y'all, this video is going to cover insulin and heparin. Insulin is just super quick. That's why I'm including it with heparin. The main thing about insulin problems is just to know it's always going to be in units and just really read what the question is asking. So this question says, client has Accucheck's AC and HS with a sliding scale. Order reads to administer regular insulin per the following sliding scale. And so this is our sliding scale. And then it says that the AC Accucheck before lunch at 11:30 was 249. How many units are we going to administer based on the sliding scale order? So all we have to do is come up here to our sliding scale, and we see that 249 falls in between 201 and 250. So we're going to administer 5 units. And that's it. That's really all there is to insulin problems. Now we're going to go to heparin, which is a little bit trickier. So with a heparin problem, you're always going to have your heparin protocol, which is what's in this box. It might not always be in a box like this. It might just be written out on your test, but you're always going to have some sort of instructions that kind of tell you, like this is what would be in the patient's chart if they were on a heparin drip. So I chose this problem because it's broken up into 3 different little problems, and it has all the components of heparin that they might ask you on a test. So we're going to start with the first one, and it says your patient weighs 200 pounds and has ivory heparin ordered per the above protocol, and it wants us to calculate the initial bolus in units. So we're going to come up to our heparin protocol in the box, and this is going to be our initial instructions right here. These first 2 things are just kind of information on the concentration of the heparin, but this is the first instructions that it gives us. So it says bolus with heparin 80 units per kilogram. So just reading that's all we need to know for this particular problem. We are going to first change this into kilograms. So 200 pounds. Let me get my calculator. And what we're going to do is do 200 divided by 2.2. So 200 divided by 2.2 equals 90.9 kilograms. So that is our patient's weight in kilograms. You will never calculate a heparin problem in pounds. You'll never really calculate any nursing problem in pounds. So that should always be your first step if they give you a weight in pounds, is to calculate it into kilograms. So now they have our patient's weight in kilograms. We're going to go back up to the order, and it says 80 units per kilogram. So all we have to do is do 80 times our kilograms. And 90.9 times 80 is 7,272 units. So that is all there is to the first part, figuring out the bolus. The reason why this comes out to just units is if you have 80 units per kilogram and you're multiplying by kilograms, the kilograms cancel out. So all you have left is units. Now we are going to move on to the next problem. And it says calculate the initial heparin infusion rate in units per hour and mils per hour. So to do that, we're going to come back up to the sentence that we use, and the next part of it says initiate heparin drip at 18 units per kilogram per hour. So I'm going to write that down here just so we can see it. 18 units per kilogram per hour. So that's what we are trying to, that's what we're using to calculate the initial heparin infusion rate. So what we're going to do first is start out, and we're going to put our kilograms that our patient weighs, 90.9 kilograms. And I set these up like chemistry stoic problems. It's just what makes sense in my head. Other people set it up differently. If you have a different way, please do whatever is easiest for you. So I put 90.9 kilograms on the top. Then I know that in order to get the kilograms to cancel out, because I just want units per hour, I'm going to have to put kilograms down here on the bottom. So I'm going to take my 18 units per kilogram per hour, and I'm going to put kilogram on the bottom. And that leaves me with 18 units per hour on the top. So once I multiply all this out and divide whatever, our kilograms will be canceled out. And our answer will just be left in units per hour. So with these kind of problems, all you do is just multiply across the top and then divide by what's on bottom. So this one, we would do 90.9 times 18. And then if that was another number other than 1, you would divide by it, but you don't have to divide by 1 because it will be the same thing. But let's say there was a 2 there. It would be 90.9 times 18 divided by 2. So once we do that, 90.9 times 18, we get 1636.2 units per hour. And it also wants us to figure out how much that is in mils per hour. So to do that, we need to come back up to the protocol and figure out the concentration of our heparin. And our heparin that we are giving is 25,000 units in 250 mils. So, and we have 1,636.2 units. So what I'm going to do is I'm going to do 1,636.2 over X because I'm looking for mils. And it gave us, come back up here, 25,000 units in 250 mils. So 25,000 units in 250 mils. So same on top, same on bottom, units, mils. Now we can cross multiply and figure out how many mils per hour is going to be our initial infusion rate for our heparin drip. So we're going to do 250 times 1,636.2. And that gave us 409,050. And then to get that by itself, you just divide both sides by 25,000. And that will give us X. So we're going to do 409,050 divided by 25,000. And that gives us 16.362 mils per hour. So now that's your answer. It's just going to depend if they ask you to round or not. So we'll just round to 16.4. So once you figure out the initial heparin rate, all you have to do is just come back up to the protocol and see what the actual concentration of your heparin is, and then just do a simple cross multiply to get the mils that you need. Now it says 6 hours later, the patient's PTT is 33 seconds. According to the protocol, what will your action be? So if we come back up to our protocol, it says all these different parameters. If our PTT is within a certain range, what we're going to do. So it said our PTT was 33 seconds. So that falls in this one, less than 35. And so it says we're going to rebolus with 80 units per kilogram, and we're going to increase the rate by 4 units per kilogram per hour. So first, I want to know how many units we're going to rebolus them with. So rebolus with 80 units per kilogram. 80 units. And we already calculated up here that our patient's weight is 90.9 kilograms. And all we have to do is multiply it by 80 again. So this ended up being the same bolus that we had for our initial bolus when we started them on their drip, just because of what their PTT level was. So we'll multiply that by 80. And so we're going to give them another bolus of 7,272 units. If it had said PTT is 47, then we would do right here and continue the current rate. If it had said it was 37, we would rebolus with 40 units per kilogram. So you just have to follow the instructions. This time it worked out to be the same as what we started our initial bolus with. So that would be our first action, is to rebolus them with 7,272 units. Our next action is going to be increase the rate by 4 units per kilogram per hour. So increase rate 4 units per kilogram per hour. So in order to do that, we have to first start out with our weight. So we're going to do 90.9 kilograms. And so I need kilograms on the bottom. And it says 4 units per kilogram. So I'm going to do per kilogram, 4 units per hour. So once we multiply, divide, that will cancel out kilograms and kick us out a number in units per hour. So if we put that in our calculator, it will be 90.9 times 4 divided by 1 is 363.6 units. And that's going to be how much we're increasing by. But in order to increase it, we're going to do it in mils per hour. So we increase the rate by that much, 4 units per kilogram per hour, which is 363.6 units per hour. But in reality, in a hospital, you're not going to be able to put on your IV pump 363 or 364 units. You're going to have to figure out how many mils per hour that is. So we're going to take that number and use our concentration that we used above to figure out how many mils per hour. So it's going to be the same steps that we just did. So we're going to take our 363.6 units, and that's going to be over, that's what we want is mils. And we have 25,000 units over 250 mils. So we're going to cross multiply 363.6 times 250 is 90,900. And then, equals 25,000x. Then we're going to divide both sides by 25,000 to get x by itself. So 90,900 divided by 25,000 is 3.636 or 3.64 mils per hour. So that's how much we're going to increase our rate by. So we're going to increase rate 3.64 mils per hour. So the question might ask how much you'll increase it by. That would be your answer. But if it asks what is your new rate, then what you would need to do is take this 3.64 and add it to this 16.4 that you already had your rate going at. So you're just going to have to read the question and see what it asks. So if it asks us what is a new rate, then we would do 16.4 plus 3.64. And so our new rate would be 20.04 or 20 mils per hour. If it just asks how much are you increasing the rate by, then you would just say you're increasing it by 3.64 mils per hour. But normally they're not going to ask you that. So that is all there is to heparin. It is a lot of steps, but it's really just knowing where to start and really reading your protocol. You're always going to start out your problems with your weight, your 90.9 kilograms or whatever kilograms is. That's the easiest place for you to start. That's what they give you. So just always make sure you turn out those pounds into kilograms, and then you can start working out your problem from there.